All right. Word of operations with powers. So coefficient. So I'm throwing out this word coefficient, right? So this, we're moving into more of like the vocabulary that comes with algebra. And one of the main things of in algebra is coefficient. Now, coefficient is simply a number, all right, that multiplies a math expression. Okay? So it's a number that multiplies a math expression. I'm sure it's now perfectly clear what that means. All right? So what this is talking about is if we look at these ones that are 4 directly below, the coefficient would be these. I'm going to highlight them. This, that, and that. Do we see that these are numbers that are out front of some other thing that's happening, right? Some operation that needs to occur. Okay? That's an expression. When we get to algebra, coefficient. This whole thing, this is an expression, but there seems to be a number that is out front of it that gets multiplied in. Now, according to order of operations, we need brackets, exponents, division, multiplication from left to right, addition, subtraction from left to right, right? It's kind of down here. So this right here, do you notice there's brackets and exponents? There's something that has to happen before we do that multiplying, all right? But all it's saying is that when we have this number that's out front of something else, it's called a coefficient. Okay? So in this case, it's a 3. It's a negative 3. What's this one here? It's a hidden 1. So it's like negative 1 and then 4 to the 4. All right? So it can be a hidden 1 and then that 6 there. All right? So, right, this tells me, according to order of operations, that this coefficient would stay out front, okay, and then it gets multiplied to my exponent, right? So I have to do 2 to the power of 4 before I can multiply it by a 3. Instead of going, so if you try to go 3 times 2 and get 6 to the power of 4, you'd be doing it wrong, right? Because you're doing multiplication, then exponents. So, does it change what we're actually been doing? No. I just gave a name to it. All right? 2 to the power of 4. Anybody know what that is off their head? Yep. 16. Perfect. And then I go 3 times 16. Ooh, this is a perfect one to half and double. All right? If I double one, I half the other. And then sometimes easier to multiply. Anybody using that trick? I think I showed it to you last year. Every day, hey Dylan? Every day. No? I'm going to get a smile out of you one day. All right. Sydney, what am I going to do next in the next question? Okay, so what's your next line going to read? Good. Why is it positive? Good. 2 negatives, make it positive. Are we writing this down? Right? And then we finish the question off. Negative 75. Grady, do you know what 4 to the 4 is? Or could you calculate it out for me? So it's 16 times 16. $625? Yeah. I know, it was on the tip of your tongue, wasn't it? Not really. Well, now you know, right? What's wrong? Is it 256? Oh, yes it is. 625 is 25 times 25. 256, thank you. And it's written right in my book as 256, but, you know. There we go, thank you. Negative 2 to the power of 3. What's that one? Have we got that one memorized yet? 8, positive or negative? Good. Positive or negative? Sorry? Negative, because we have 3 of them. Right? We good? And then negative 48. Let's get a little bigger. Now, let's go to that one. So we have 4 squared minus 8, all being divided by a 2 minus 7 in brackets plus a negative 3 squared. Okay? Now, brackets, exponents, I kind of do all at the same time, as long as they don't interfere with each other, right? So and I do the numerator by itself, and I do the denominator by itself, because eventually we're going to have to divide. Okay? Matthew, can I do anything on the top in the first step?
Yeah.
What do you got?
4 to the power of 2.
Which is?
16.
Good. 16 minus 8. I'm going to stop there. Rebecca, what would you like to do in the denominator? And what do you get there? Positive or negative? Sure?
Negative.
Good. And anything else you want to do there?
No, 2 to the power of 2.
Yeah, because these guys are independent of each other, right? They're being added together. One doesn't depend on the other one. And what's negative 3 squared? Good. Right? So I could do this, and I could do this. None of them all hinge on each other, right? Brooke, what do you want to do after that?
16 minus 8.
Is?
8.
And what's your denominator?
4.
And do you want to leave it like that, or do you think you can go farther? Exactly. Perfect. Sorry, did somebody say what? 8 divided by 4. Yep. All right, this one. Okay, so again, this is very similar to this is exactly the same thing as what we were doing last year, right? Look for things that you can do. Like look for the, remember, I think I called it breaking it into pieces last year, right? Can we break the question into pieces? And what creates the pieces is the very last step of adding and subtracting, right? Look at this question. Do we see that there is a subtraction sign right there? And an adding symbol right there. So how many pieces are to this question? 3. Could I do each of the pieces separately? Could I do this, and then go and do that, and then go and do that? And then what would I do with the pieces after that? Add and subtract them. Okay? 4 squared is?
16.
Good. And then I'm going to subtract. 8 divided by 2 is? 4. And then I'm going to add. A negative 3 squared is? 9. So really I did brackets. I didn't have any brackets. I did exponents and any division, right? Now I'm left with an adding and subtracting question. 16 minus 4 gives me 12 plus 9, 21. Brooke, can you grab the door again? Mr. Stewart has such a exuberant over there. Not like this in here. No, there's none of that going on in here. Never. All right, let's look at the next question. How many pieces are there to this question? 2. Who said 2? Why, Rebecca?
Because
Right, there it is. Right, there's the adding sign. That breaks it into this piece here and this piece here. So it's like two mini questions put together. Taylor, what do you want to do in the first one? Good. So what's 4 squared? Good. So -2, bracket, -15, and subtract the 16. Good. Dylan, what's next? I'm just working with this front one. Let's do that one first. No? So I always think of, I break it into like, if I had 15 and 15, what would be 15 and 15? What's 15 and 15? 30, and then there's an extra 1, because this guy's 16. So then I'd have 31. I'd have -31. Because they're both negative, same signs, keep an add, right? And then I'd multiply them together, and I would get a positive 62. On the right-hand side, Matthew, what would I do first?
3 to the power of 2 plus 3.
Okay, so before I get to the exponent, what should I do first, though?
Oh, bracket.
Brackets.
So 2 plus 3.
Is
5.
5 to the power of 3. Do you remember that?
Yeah, it's 125.
Good. And if I have $1.25, if I had 4 of those, how much money would I have?
500.
I'd have 500. So I have 562. Okay, so they're going to have questions like that. Second question is the ones with the substitution in it, right? So substitution last year was just really literally added one step to the question, right? I take out the B, I put in a 5. I take out the A, I put in a 2. So I rewrite the question, 8 bracket, 5 plus 2, close the bracket, squared, minus 12 divided by 2 squared. And I don't need to put any extra brackets in because I didn't substitute any negatives in, right? Give this one a try. See if you can finish it off for me. Want to try it out, Matthew?
Sure.
Good.
Which side? The left one?
Yep, this guy right here. Finish him off.
5 plus 2.
Oh, no, do it in your head. All right, so let's check yours. I would have done that first, right? I would have gone 8 times a 7 squared minus the 12 divided by, and you could have easily done all this one too, but I'm going to do it in the next step. 8 times 49 minus 12 divided by 4. So far, so good? 8 times 49, half and doubling doesn't really work for this one because you can't half 49. So, but if you punch it in your calculator, you get a 392. And then 12 divided by 4 is 3, which gives me a 389. How many had it correct? Perfect. All right, then let's set this guy up. This time I threw an integer in. All right? So I've got a bracket, 3 plus 5 squared minus 4. What's happening between the 4 and the a squared? Multiplication, right? So I'm going to put a bracket around it because I'm going to need to multiply. This is a coefficient. This 4 here is the coefficient. Okay, try that one on your own. Let's finish that one up. All right. So I'm going to go and do that. All right, because that's brackets. 8 squared minus 4 times a negative 3 squared. Then I'm going to go do all my exponents. 64 minus a 4. Did we get a positive 9? Did we remember that squaring a negative gave me a positive? And then I get 64 minus a 36. I'm going to borrow in my mind. That gives me what, an 8? And that's down to a 5 minus 3, which is 2. Did I do it right? Yes, I did. And it's positive, right? Because I have more positives are that. How many got that one? Yay. What happened?
I changed the subtraction to addition.
Right in here?
Yeah.
Oh. Yeah. Did you, like, get rid of this sign? Is that what you did?
Yeah.
Oh, okay. Yeah, you got to be careful. Don't do that. All right. Write an expression that shows the area and the volume of two squares with sides of 12 and 9. Okay. So we have a square. Why do I have to do it twice? Why did I do it twice? Oh, I missed the word show the difference. There we go. Difference between. I was wondering why I gave 2 squares and 2 rectangles. All right, let's do area first. How do I find the area of a square? I shall draw you a square. There is a square. It's what? Side times side, right? So essentially it's side squared. What does difference mean? Find the difference between them. What operation is difference? It is subtraction. Good. So I'm going to find the difference between the area of those two squares. So how do I calculate the area of the first square? Knowing that the formula is side squared. What's the side length of the first square? $12. Right? What's the side length of the second square? 9. So this is what we would do. We would take the area of the first square and I would subtract the area of the second square. That would give me the difference. No, I should go area equals. Now I'm just going, I should maybe go down. Let's go down. Because you know how much right, this is the area. I don't want to do that. 12 squared minus 9 squared. Now I just have to make sure that I do the math of it, right? 144 minus 81 gives me a difference of, what is that? Oh, my brain's not working quickly. 63? Thank you. And I'm in centimeters squared because it's area. So that would be the difference between those two. Does that make sense? Could I do it for volume? Does anybody remember the volume formula? So essentially it's taking this guy and making it look like that. Yes, length times width times height, which is, if length, width, and height are all the same, side cubed. Oh, there we are, side cubed. So I would go 12 cubed minus 9 cubed. And I definitely don't know what 12 cubed is in my head. 12 times 12 times 12. So 12 cubed is 1728. minus 9 cubed is 729. So their volumes, if I subtract them, will be 999 centimeters cubed. Did that make sense? Yeah. So these formulas right here, especially, you notice they come up a lot when we work with powers because they are beautiful little formulas with lots of powers in them. All right, what do we got on the second page? Oh, just some random questions. We got 3 left. What do we got for time? What time is the bell? 2 o'clock? Okay, we have. Where do we start? What should we do first? Exponents. I'm just going to go left to right, right? But I can't do these ones, right? I can only do that and that, right? Does that make sense? Because I have to figure out everything that's in those brackets first before I can square them and before I can square the other one. So, 3, could I, instead of figuring it out separately, could I use the exponent laws? What is 3 squared times 3 to the 3? 3 to the power of 5. Look at that. I did that one. Yeah, nope. Could I put these guys together with the exponent laws? Yeah? What do you got, Grady?
4 to the power of 5.
Good. Look how that... Could I keep going with the exponent laws? Yeah. Rebecca, what do I get for the first one? Good. And 4 to the power, Matthew, of? 10. Now, can I keep going? Is there a rule for subtraction? No. If I wanted to do it, what's the only thing I can do now? 100 in my calculator. Okay? Let's do that. These are going to be jumbo numbers, so let's do it all together. 3 to the power of 15 minus 4 to the power of 10. Right? Rather than doing it, I'm just going to punch the whole thing in. Because otherwise, 3 to the power of 15 is a very large number. We don't need to write that down. So let's just put it all in our calculator at once. And then give myself that answer. 13,300,331. So I used the product rule, product law. Then I used the power law, right? And then I just did math. Got my answer. B. Take a look at this one. Is there any in here that I could simplify this thing up using an exponent law? Can I use an exponent law on this first one? Nah, not to make it easier. No. What about this one? Could I use an exponent law to make that one easier? Which one? Good. Yeah, division law, right? This guy right here is the division law. Subtract exponents. I'm going to multiply that and get 42 squared there. And then 3 to the 8 divided by 3 to the 6 will give me 3 to the 2, which makes so much easier to calculate other than the 42 squared. 42 squared gives me 1764. What's this guy? Could I use the one more rule? One more law? What would I do with the exponents, Matthew?
2 times 3.
Yeah, there's my power law again. And I get a 6. So then in my next step, I could calculate that. 1764 plus a 729. And the reason I can do that now is because there's an adding symbol there. And I end up with I want you to take a look at C before you even do the question. Before you even do the question. When you have a 0 in there, right? What's anything to the power of 0? 1. Now, I want you to think about it. Inside the bracket, what would you be doing? Sorry? You would be doing some math, right? You would be taking these two terms. Could you use a power law at all? Like, could you use the product law? Add the exponent. No, they're being added in the middle. So you would figure this out, right? You would figure this out, and what would you do with those two answers? You would add them together, right? So I would get, like, what, negative 125 and whatever this thing is, and I would add them together, and I would get a single number. And that single number would be to the power of 0. So if I have something to the power of 0, what's my answer going to be? 1. It doesn't matter what I do here. All of this is going to be wiped out by that 0, and this answer is going to be simply 1. If it's still negative inside the bracket, it still will be. Yep. It's only when you have it, like if you had a negative out front right there, then you would have that. So this is negative 125 plus, I think that one's going to be positive, right? 625, right? Negative 125 plus 625. If you did, you're going to get a 500, but that's going to be all to the power of 0. 500 to the power of 0 is 1. But you went through all this work. So sometimes, look at a question. Could I logically look at my answer and go, hey, this is all going to, because we can't do this exponent on the outside until that whole bracket is one thing. And if I make that whole bracket one thing, I'm still to the power of 0. It's going to be 1 no matter what. So sometimes, yeah. See, this is why I like math. It's kind of cool. It eliminated all those steps, right? I didn't have to do them. It's kind of like that test that you get sometimes in elementary where it says, you know, put your name in the top right-hand corner. You're supposed to read over the whole test, and it's, you know, on the second line, or the bottom of the question, the last question, it says, if you read the instructions all the way down to this line, just put your name in the top right-hand corner and hand it in. Have you ever seen that test? It had like 17 different instructions, like, and then the very last one is, because the first, number 1 says, please read the entire test first before doing anything. And the very last instruction is, if you read all of this, put your name in the top right-hand corner and hand it in. Good. So, look at your question. Can you simplify something before, or go, hey, it doesn't matter what I do inside of those brackets, it's going to be to the power of 0, it's going to be a 1 anyways. All right. That is a lot of info, but you have the rest of today, which isn't a lot, it's like 3 minutes, but you have all of tomorrow, and probably maybe even some time after that, but you have like, I think I gave you like 6 or 8 pages, but I gave you lots of space, so that is what you're working on.